All right. It depends on whether I'm facing down or not, because it's still kind of sensitive. Do you want it or not? I mean, it's okay? All right. We'll give it a try. If you guys don't like it, I'll take it back and just put it back in the box. All right, so let's go ahead and get started with today's class. Your homework was due about 40 seconds ago, okay? My watch is actually synchronized to the atomic clock, so is the server. So I'm pretty sure about the time, maybe off by a second at the most. So how was the homework assignment? Was it hard, easy?
A little bit hard.
A little bit hard. Okay, which part is hard? Was it the concept part or really just the algorithm part? Yep.
The part that fraction should become like a simplified fraction. That part was a little bit tricky.
Okay.
And search Google, go around, and
okay.
Just go to the other side and go and find out that.
Okay.
Yeah.
So what I'll do today is the first part. I thought about this a little bit, whether I should just put this all into the lab time. But since I'm giving you a new homework assignment, I would much rather spend the lab time on the new homework assignment. So what I'll do is I'm going to go over today's homework assignment, and I'll just go ahead and do it myself. Okay, since you have done it already. Live support just got cut off. So there's no hum from the air conditioning. It's gone. I don't know what is happening, but they just cut off air circulation. So if it gets really too stuffy, I suppose we'll just cancel the class. But for now, we're still okay. Somebody has to keep an eye on the oxygen level in the classroom. When I see people starting to pass out, in the class, then I'll contact the maintenance and go like, something is not right. Okay, so your new homework assignment. So I'll talk about the new homework assignment first. Oh, there we go. Life support is back. They probably diverted all energy to shield or weapon, and cut off life support. We're fighting the Klingons, so you gotta use your energy, wisely. All right, so this is your new homework assignment. The new homework assignment, the title is actually misleading. It's not to factor a bunch of fractions. You are going to find the least common denominator given a whole bunch of fractions, and then you have to convert all the fractions to use the least common denominator, and then change the numerators so they still represent the same value. Okay, so that's your new homework assignment. So you might want to keep in mind what you have to do with this one. The idea is it will use arrays. I will give you an array of fractions. The fractions are kind of like the one before with a numerator and a denominator. But your job is to go through the array, okay, find out what is the least common denominator of all the fractions. Once you find that out, you have to make adjustments to each fraction so that the numerator will be adjusted as well as the denominator. So each one of the fractions will still be representing the same value as before, but they will all have the same denominator, which is basically what you have to do when you want to do addition or subtraction with fractions. So in terms of concept, it's nothing new. It's just how do you write it out as an algorithm. Okay, I'll give you one example, and then we'll move on and talk about the homework that was due earlier today. And what I'll do is I'm going to illustrate how I would approach the problem and see if that is helpful. All right. So I'll just give you an example. Okay, what are you going to do when you have to add a quarter to a third? Well, 4 and 3 are not the same, so you have to find the common denominator, right? So the least common denominator in this case is 12. So 1/4 can now be represented as 3 over 12. The other one is 4 over 12. And since they do have the same common denominator at this point, you can then perform the addition, and it becomes 7 over 12. Okay, so it's the same kind of thing that you have to do with this one, except I just want you to change each fraction so that they all have the same least common denominator. And then you have to make adjustments to the numerator, so each fraction will still be representing the same value. So are there any questions about the new homework assignment, what you're supposed to do? Questions? Yep, go ahead.
It should be really helpful to get like input and output like last time.
Right, the input and output will be done by the main subroutine, and it will be calling a subroutine that we have written already. So you can copy and paste code, as appropriate. Sorry?
Is there a certain size the array will be?
The size of the array?
Yeah.
Yes, it will be given to your subroutine. So you're supposed to write a subroutine, you'll be given the array and also the number of elements in the array.
Okay.
So it's not going to be fixed, it's going to be one of the parameters.
Okay.
All right. Okay, so what we'll do is we'll go back to the, go ahead.
Yeah. What if one of the denominators is a factor of the other denominator?
Then, well, it doesn't change the meaning of the least common denominator, right? So if you have a case where you have a quarter and an eighth, okay? So in this case, the least common denominator will still be the 8 because 4 is less than 8, but you cannot factor the other number. Is that answering your question? All right. So with this kind of out of the way, we'll kind of go back to the previous homework assignment. And I know most of you were able to get it done, but I am going to do it anyway, just to kind of illustrate, how I would approach the problem. So we'll go to fraction math, which is the one that you just turned in. Some of you turned it in like a week ago, okay, so I know you didn't just turn it in. All right, so we will go ahead and write the subroutine. I'll use this one here. All right, so to create a folder called simplify, go into the subfolder simplify, and then we first create the fraction.h file, fraction.h. I'll do some copy and pasting here. Copy and oops, paste. There we go. And then we'll copy and paste the beginning part of the main program, which is this part here. So we copy, and this is mains.cpp. So we'll do a paste. Control D, there we go. All right. So this is my main program. I have to implement all 3 subroutines. To implement the 3 subroutines, we'll have to go take a look at what the subroutines are supposed to do, and then we'll go ahead and give it a try. The 3 subroutines would be fraction simplify, fraction scan, and also fraction print. We'll go ahead and do with fraction scan first, okay? So we look at fraction scan, and it says this is a subroutine to use scanf to read the fraction of the format a number divided by / another number, and store that to the fraction pointed to by the parameter pf. Note that each number should be an unsigned number. Like readnum in the previous assignment, this function should also check for errors and recover from errors. So you can basically recycle the logic from the previous homework assignment, including my solution. Okay, you can borrow my solution, but you still have to make modifications to it because the return value of scanf is -1, 0, 1, and 2 this time. So that's why it won't be exactly the same as last time. So we have void fraction scan struct fraction pf, and we will now specify the content. So within the content here, we have to. There are several things you can do. Okay, the first thing what I would do is I'm going to store the result of scanf. So I would say scanf result. Make it a local variable. Nobody else need to know about the result of scanf other than this particular subroutine. So I make it a local variable of this subroutine. And we know this is going to be a loop, because what if you try to scan a fraction, but it is not a fraction? It gives you a 0 or 1, which means a part of it is a fraction, but not the entire thing. So you need a loop to do this. To make this loop work, there are several ways to do it. If you are using the previous homework assignment as a clue, I was using a while loop here, and this is the general structure of the while loop. So if you use a while loop, you basically have to say, okay, what is the condition of this while loop? Well, you stay in the while loop as long as you cannot read a fraction, and it is not end of file yet, right? Because as long as you're able to scan something, or something is in the input, but it's not what you want, you have to recover the error and try again, okay? Right. So I will just write a comment here and say, as long as the not end of file and not reading a fraction, then we stay in the loop. All right. So the next question now is, how do we express that? How do we express, as long as it is not end of file and we are not reading a fraction? Well, you don't know whether it is end of file or you're reading a fraction or not until you try. Okay, until you actually do a scanf and say, okay, I'll give it a try. I'm going to try to read a fraction. So we know the scanf with a format string of %u/%u is going to be here. Okay, that much we know for sure. Because until you try, you don't know whether there's a problem or not. Next question is, where am I going to store the numbers that I'm reading in? Well, let's see. The only thing you can read into at this point would be scan result. I don't want to read into scan result. Scan result is supposed to store the return value of scanf, but we are not going to scan into scan result. So what we want to do is to find some kind of unsigned integer. And by the way, scan result is an integer. It's not even unsigned integer, so that doesn't make any sense. Okay, so the other thing that we are given with is PF. Okay, let's start with that. What is PF? It's a pointer, okay? It's a pointer to something, but first of all, it is a pointer. What is the only thing we can do with a pointer at this time of this class? Okay, later on we can do other fancy stuff, but there's only one thing we can do at this point. Dereferencing, okay, very good. So we can dereference, PF, okay? Oh, by the way, do I want to store something into the pointer itself? No. Okay, so we can dereference it. Let me see, here. And the dereference operator is the asterisk operator. After I dereference PF, which is a pointer, what do I get? It is a pointer of what? It's a pointer of a fraction, okay? So once I dereference, I have a fraction. Well, that's kind of good, okay? So when you look at the entire thing, which is asterisk PF, I have a structure, I have a fraction. Should I just read into the entire fraction? Is the entire fraction a single unsigned integer? It's not. I want a particular unsigned integer. Well, the first part is an unsigned integer, so it's the second part. I just have to pick one, right? The first placeholder goes to the first part, so I need to now specify, I just want to read it into the numerator. So now I have an unsigned integer. But then the compiler will come back and complain and say, hey, scanf is supposed to have a pointer to an unsigned integer, not an unsigned integer. So how should I fix this problem? I have to take the address of this particular unsigned integer. So I have to apply the ampersand operator on the whole thing. So I would just put in extra parentheses just to be sure. Yep.
So the ampersand is supposed to undo the asterisk, right?
Not necessarily, not in this case, because the asterisk applies to a pointer to a fraction, but the ampersand applies to a member of that structure. So they're not exactly undoing each other. In other words, the pointer is, okay, what I'm given with is the address of an entire apartment complex. Okay? And dot numerator means, I want to go to a particular apartment. But I'm not interested in the apartment itself, I'm interested in the address of the apartment. So I start off with the address of the entire apartment complex, but I end up with the address of a particular apartment in the apartment complex. So that's why they're not really canceling each other. I think the mic is acting funny, it's not me. Just want to be.
Is there any way to turn down?
I turned down a little bit already, but if I turn down any further, I think there won't be any actual amplification. So we'll give it a try. Is it still amplified a little bit? No, exactly. So if I turn on just a little bit, it's already getting saturated. I think we can conclude that this experiment was not successful. Maybe I should just go to Harbor Freight and pick up a megaphone. That'll work better. And they're cheap too. You know, especially when you wait until Harbor Freight has a sale and then apply the 20% on top of that, and then get a free flashlight or a multimeter. Those are good deals. Everybody should have a multimeter, and I should say at least one. Keep one in the backpack, one in the trunk, one at home. You know, they're always useful. You never know when your battery is going weak. Okay, so that's the first one. The second one is pretty much the same thing, except we want the address of the second member, which is our denominator. Denominator, like that. Okay, so that's my scanf, and it's already kind of long on the line, but we are not even done yet, right? So if you look at this parenthesis, it is matching the end. You know, this is why I like VI, you know, or a intelligent editor. When you go to a opening of a parenthesis, it will match the end, so it's easier to match, you know, where's the beginning and where's the end. Okay, now we have a scanf, but this scanf may not be successful, right? What are the possible values that this particular scanf can return? It can return, go ahead.
-1.
-1 if it's in a file, 0 if it cannot read a single number, 1 if it can read the first number but not a slash or the second number, or 2 if it can read a number, a slash, and the second number. Okay. And I can't really just say, you know, if this is 0, stay in the loop. Okay, because if it's 1, I also want to stay in the loop. So what I need to do is to say, okay, let's go ahead and store that into an integer first. Okay. So I know this is getting a little bit hairy because I'm doing it this way. So we have an assignment operation inside the condition of a while loop. I'm not particularly interested in just scan result here because one value of scan result, which is 2 values, I should say. There are 2 values of scan result that I cannot do much about, or, you know, it is a good thing. If it's -1, I should get out because there's nothing I can do about end of file. I cannot recover from end of file. If it is reading 2 values into the numerator and the denominator, then I'm done. So I can exit as well in that case. So what I need to do now is to say, the first part is not important. I'm using the comma expression here. Does anyone still remember the comma expression? What does it mean? If I have 1, 2, 3 as an expression, what is the value of that expression? 3 is the last one. Okay. So this means, you know, the first operation, which is the assignment operation, I really don't care about the value of that expression. It is whatever is following that is important. Okay. So whatever following here is the actual condition to stay in the loop. And I'm going to use parentheses here to indicate what it is. So I'm going to say I want to stay in the loop as long as scanf result is greater than 0. Greater than or equal to 0, excuse me. Okay. Because if it's -1, I cannot do much about end of file. I should exit the loop already. I also want scanf result to be less than 2, because if it is 2, that means I have just read 2 numbers into the numerator and the denominator, and I'm done over there. So I also want scanf result to be less than 2. So I'm going to use this as the condition of this particular loop. I know this is really long as a condition, but it is one way to solve this problem. This is one way to express the solution of this problem. So to make it slightly easier to read, I'm going to move the comment onto another line just so it doesn't wrap around like that. So if I get into this loop, what is guaranteed to be scanf results value. It can be, if I'm here, if I'm on line 11, what do I know about the value of scanf result? It can be, cannot be 0, because if it's, I take it back, it can be 0, it can also be 1, okay? If it's a 0 or 1, that means, there's something in the input file, it's just not, a number followed by slash and then another number. So what I would do here is to say, same thing that I did with the previous program, use a local variable ch and just say, let's get rid of that, junk character. That's all I'm gonna do. Read it in, toss it away, because it is in the way of reading in an actual fraction. So this is one way to implement fraction scan. It's not the only way to do it, okay? It's one of the many ways to do it. But this one resembles how I solved the problem in the previous program the most. Okay, so that's why I chose to do it this way. Are there any questions about the way I did fraction scan? Okay, if I were doing this homework assignment, I would stop here and just make stubs of the other subroutines and then test the program. There are several things you can do here. One thing you can also do is just to comment out the call to the other subroutines so that the compiler would not complain about it. And also, since I'm using scanf, I have to do another pound include here to pound include stdio.h, because every time you use printf or scanf, you have to do that. The tech, this is not going to work. How do you know whether you read the correct fraction into the fraction or not? Because I have not even implemented fraction print yet. Well, GDB can do it, okay? So I can do this all in GDB. So that's what I'm going to do. G++ -wall -g-c main.cpp, and then we'll do the linking. G++ -o main.o GDB main. Put a breakpoint. Well, let's take a look at the program. Put a breakpoint on line 22. I'm fairly confident this code is working, so I'm just going to put a breakpoint at the end. Run the program, give it some gibberish, and then give it a fraction. Well, something that looks like a fraction, but it's not, because I'm going to put a comma here, which is going to interfere with the interpretation of a fraction. And then I'll give it an actual fraction like 4/5. Press the enter key. Okay, it seems to get out correctly, but the question now is, did I read the right numbers into the fraction? So what I'll do is I'm going to say printf, and f is the local variable of the type structure, fraction, and it does have 4 as a numerator and 5 as a denominator. So this is confirmation that I have, a fraction scan implemented correctly, and I would not go forward until this particular subroutine is all done, because otherwise it's kind of pointless to implement another subroutine. You don't have to do it this way. You can implement fraction simplify first, okay? But what you will need to do is to basically have a way to initialize your fraction for testing purposes, and then call the subroutine, and then come back and check and see if it's correct. Okay. All right. So if this is done, then we'll go back, and then we'll start on the next subroutine. The next subroutine that I'm going to implement is going to be, well, I'll do the easy one first, okay? Fraction print is the easy one. And according to the homework assignment description, print is also going to be given a pointer to a fraction structure. So we'll say structure fraction, PF, just like the other one. And it has one single printf. %u/%u, the same format string as before. And this time I want to give it 2 unsigned integers. So we can pretty much copy and paste almost exactly the same thing as last time, except I don't need the ampersand. Because when you're printing, you only want to print the value of something. You're not going to print the address of that thing. So that's why when you're printing, we just need the member, the value of the member, which is PF, dereference PF first, and then use the dot notation to access numerator. And then the same thing for the other one, except this time we want the denominator. Okay. So this is my second subroutine, and uncomment, that one. So we'll take a look. I'm just going to repeat the command here. So 506 and 507. And this one I can actually just run it, okay, because I have the print now. So we'll just go ahead and test it. 5/6 is printed out at 5/6. It's all working. So I'm saving the best for last, okay? The simplified logic, right? So now we go back in and we think about the simplified logic. The prototype of the function is fraction simplify, and once again we are given a pointer to a fraction structure. So this way, when you're doing the simplification, you are changing the fraction right away. You're not going to return it as a return value. You are actually changing the fraction that is pointed to by PF. So with this one, we kind of have to think about it first, okay? How do you simplify, fractions by hand? The numerator is not the important part, okay? Because once you figure out how to deal with the denominator, you're just kind of mirroring the same operation to the numerator. Now I take it back. Since we are simplifying a single number, we look at the numerator and then we look at the denominator, and we try to find common factors until such a common factor cannot be found. Okay. So do you think this is going to be a loop? It sounds like something that's repetitive, right? The reason why I think this is going to be repetitive is, what if you have like 1024, which is a power of 2, divided by 1024. Each time you will find a factor of 2, then it becomes 512 over 512, then it becomes 256 over 256, and so on. So you have to do it like 10 times to reduce it all the way down to 1 over 1. So we know kind of this is going to be a loop. Whenever you think something is a loop, you have to think about the exit condition. What does it mean when I'm getting out of this loop? So this is what we'll do. Okay? So what we'll do is we're going to say while blah blah blah, do some action here. But I'm going to say, what is the condition? Okay? As long as the number can be factored. As long as n and d can be factored, stay in this loop. That's kind of the condition. But how do I know that n and d can still be factored? Well, I have to give it a try, right? I have to say, well, let's try this factor, let's try that factor, and so on. Okay. So that's one loop. The other loop is, how do you know, what is a factor given the numerator and the denominator? Now, for 1024 and 1024, it's easy because, we have that rule of thumb, right? If the least significant digit in base 10 is 2, 4, 6, 8, or 0, we know it's divisible by 2. Do you guys have a question?
No. Oh, sorry.
Okay. But if you do, that's okay. You can just go ahead and ask the question. Anything I can answer?
No, we were going on the next assignment.
Oh, okay. So let's kind of wait until the lab time. So this one is easy, but you have to kind of think about a larger number, and then you have to really think about it in a structured way, and then you can come up with the algorithm. In other words, what if I give you this number instead? Let's see. Let's just make sure that this will work. We'll just make another one here that will work, and we'll make another number here for the 2. Let's see. 2, okay. Go ahead and simplify that. Well, none of the rule of thumb will work. Okay, it's not divisible by 2, not 3. I double checked. Not 5, right? So what are you going to do now?
That's good fun.
You have to keep going, okay? So you have to say, okay, let's try 6, let's try 7, let's try 8, and so on. When do you stop?
Where do you reach that number?
When you find a factor that is divisible by both of them, or you have reached at least one of the two numbers, right? If the potential factor has reached one of these two numbers, you can stop and say that, oh, there are no common factors between these two numbers. Does that make any sense? Okay. So that means, I also need a second loop to basically say, well, let's, we have to find a common factor first, okay? So I'm going to write that loop separately, okay, in parallel. And I can basically put this loop as long as f is not a common factor and f is not one of the two numbers, then we'll go ahead and keep trying. Okay? All right. Well, that's a good start, okay? Because this will give me at least one common factor, or at least tell me whether there is a common factor or not. So I'll go ahead and solve this problem first. I'll forget about the first one, because that's kind of like the outer loop. So I'll just kind of say, let's not worry about the outer loop for the time being, and just worry about getting a single common factor first. Because if I can find one single common factor, then I can repeat that process to find all of the other ones. Okay. Now that I know the condition to stay in the loop is f is not a common factor of the two numbers, and f is not one of the two numbers, can I express that using comparisons and stuff like that? We can kind of assume that there's a local variable f. In fact, I'll just make it here. So unsigned or UN32 underscore T f, this is the potential factor. So given that we have a potential factor f, how do we say that f is not a common factor? In other words, f is not the factor of just one of the two numbers.
We use end statement. We use end statement.
Okay.
We have to try to run.
Okay, so the way I would do this is to find out the components first, okay? So I'm going to specify the two components. The first component is to say, let's take a look at the numerator, okay? Numerator. And the result of dividing the numerator by f, and we'll focus on the remainder, okay? If the remainder of this division is a 0, it means it is a factor. If it is non-zero, it means it is not a factor, okay? So what I'll do is I'm looking for not a 0. And I'm going to do the same thing here, okay? Because, that's a reason to stay in the loop. Denominator %f is not 0. Okay, so now I can say the first one confirms that f is not a factor of the numerator. The second one confirms that f is not a factor of the denominator. The question now is, what should I put here in order to stay in the loop? In order to stay in the loop, as if you read line 28, as long as f is not a common factor, what is a common factor? It is a factor of both. So not a factor means f is not a factor of at least one of them. Is that right? So what should I put here? Should I put an and here, or should I put an or here?
Or.
Or is correct, because if f is not a factor of at least one of these two numbers, I cannot get out yet, because I haven't found a factor yet. Okay, that's good. That's the first one. We also have a second condition to deal with, which is f is not one of these two numbers. Because if I keep adding 1 to f and it becomes one of the two numbers, then I should get out, because it means that these two numbers do not have a common factor. Okay? So how do I express that condition? So we know that we'll be looking at the numerator again, and this time we'll be comparing that to f. Okay? So we'll be saying, okay, does it equal to f? And then we'll have an operator here, and then the other one will be comparing the denominator, and comparing that to f2, and see if it's equal. So once again, I have a question mark here representing a logical operator. In other words, on one side, on the left-hand side, I confirm that the factor is the numerator now, and then on the right-hand side, I can confirm that f is the denominator. What should I put in between to say that, well, if this is the case, don't exit yet, okay? Stay in the loop. Or should I change the condition? So what I think we should do is we should change the condition to be not equal to, and then put and in here. Because to stay in the loop, f cannot be one of the two numbers, which is the same as saying f does not equal to the numerator and f does not equal to the denominator. Because as soon as it equals to one of the other two, it's time to get out. Is that okay so far? All right, so this is the whole condition of this loop here. And I have to group the parentheses correctly. So I need one more here, and then one more to end the entire thing. Okay, this is already ending the whole thing. That's because that's matching that. That is matching. Okay. I don't really need a parenthesis over there. Okay. All right. So now we have one big condition on line 27. So let's consider the whole thing on line 27 as one condition, and then we'll look at the whole thing on line 28 as another, big long condition. And I'm just double checking the grouping of the parentheses. Okay, so it's all grouped correctly now. What should I do to connect these two? You can see from the line of comment, that actually spells out the answer already. What should I use as a connective or logical operator to connect the long expression on line 27 to the long expression of line 28? And that's correct, because in the line of comments I use an and here. Okay, so we put an ampersand here. So I'm just double checking on the grouping of the parentheses. So everything is good. All right, what do we do in this loop? We have a super duper complicated condition of this loop, but inside the loop here, what are we actually going to do?
We're gonna simplify.
Bump up f. Okay, because all we are saying in the condition is f is not a common factor, and yet it has not reached one of the two numbers yet. So I haven't found what I'm looking for. Let's bump it up and try out the next number. That's all we're going to do. So we say plus f here, okay, semicolon. And you know what? I'm just going to run the program as it is here. Okay, and we'll put a breakpoint on line 34 just to be sure that I can, in fact, find a common factor of two numbers. I'm not even going to go any further than this until I confirm this logic is correct. Okay. Now, I'm fairly sure this is correct, but there's always an off chance that I'm wrong, and I don't want to move forward with only the assumption that this code is working. Okay. So we'll go ahead and save the program. I think it's 507 and 508. Nope, 506 and 507. 506 and 507. And we'll go ahead and this time I'll use GDB because there's no other way to confirm that this code is working or not. I will go ahead and list the program. I'm going to list line 20 because fraction simplify is the subroutine that I'm interested in. I'll put a breakpoint on line 34, which is right after the loop. And then we run the program. We'll give it a number that we actually can factor, okay, just to see. Yep, go ahead.
Was your fraction simplify function still commented out?
Say, which one?
Was the call to the fraction simplify still commented out?
It is. Good point. Okay, I can fix that. So let me just give it the fraction first. It's not going to do anything, but instead this time we'll say stop in fraction simplify, and then I'll run the program again. Okay, so this time let's give it something that actually can be factored. Let's give it something a little bit more chewy, like 49 and 91. Okay, that one is not obvious. Okay, because the common factor is 7. 91 is 7 times 13. It's one of the number where people think, hey, that seems like a prime number, but it's not. It still exists. Oh, that's because I didn't. Okay, fine. Let's list the main program, and this time we'll put the breakpoint on line 40. There we go. Try again. 49 over 91, and this time it stops because I put a breakpoint here. Then I can say call the subroutine fraction simplify with the address of f, and will be abandoned. I cannot call that. Okay. History is empty. Fine. Okay. Seems like there's no other way to get around this one. I have to uncomment the call to the subroutine to trigger the execution. 506, 507, and GDB main. Put a breakpoint in fraction. Simplify. Run the program, give it the same numbers, 49 divided by 91. Now we're in the subroutine. Okay. Now that we're in the subroutine, we'll go ahead and put a breakpoint on line 34, which is right before the whole thing ends. And then we continue execution. And it's an endless loop. It does not exit. I forgot to do one little thing. What did I forget to do? F was not initialized, was it? Okay. So let's go ahead and do it. Okay. Everybody has a favorite mistake to make in programming, and this is one of mine. Forgetting to initialize the variable before, or forgetting to increment. Oh, this is the wrong place to put it. So I'm going to put it right before the loop, which is here. Okay, there we go. All right, so let's go ahead and try it one more time. 506, 507, and then GDB main. Getting back to the mistake, did you guys see how quickly I was able to tell what went wrong with the program? Because those are my favorite mistakes. I would look for those first, okay? So I would usually forget to either initialize the variable before the loop, or forget to increment the variable in the loop. And the second one will get stuck in an infinite loop. The first one will just go to la la land because it's a random number. But those are my favorite mistakes, so I would look for those first. You will probably find out what your favorite mistakes are, which is okay. Everybody makes mistakes. As long as you know what yours are, you will have efficiency when it's time to debug your program. So put a breakpoint in fraction, simplify again. Run the program, 49 divided by 91, and we'll list the program, put a breakpoint on line 35, continue the execution. Now we are at line 35. This is the moment of truth, because what do you think F should be? Should be 7. Okay, and it doesn't like that. I cannot keep track of that. Fine, let's run it again. 49 divided by 91. I'll just go ahead and single step. Increment, increment. And you can always just go ahead and print F, occasionally. This is 5. Increment. It should be 6 now. Single step. Should be 7 now. Okay, so this is the iteration where it should exit. Okay.
You're saying print the number, not print the variable.
Oh, great. How about that?
There you go.
Thank you. Single step, and it does exit. Okay. So the algorithm does, do it correctly. Okay, it finds the common factor. So now we can find a common factor between the numerator and the denominator. What is left to do is to say, hey, let's keep doing this until I can no longer do this, right? So we go back to the main program and go to fraction simplify and say from line 27 to line 34, well, we'll just say that from line 27, okay? Because line 27 does not need to be a part of the outer loop, but we'll just say that it is. So what we want to do is to keep doing this, keep doing line 27 all the way up to line 34 until it can no longer be done, okay, until f is not a factor of these two numbers anymore. Then we can quit. We can say, okay, we're all done. Okay, so that means we need another loop on top of this one. But the other loop that is on top of this one, it doesn't make sense to make it a while loop, okay? Because I cannot get out of the outer loop until I have tried the inner loop at least once. At least try it once to find a common factor. So that means the outer loop should be a do loop, okay? It should be a do while loop, which means we are checking the condition after the loop here. And I would say, until what? Well, until there are no common factors, okay? Which means as long as there are, common factors, we want to stay in the outer loop. Are we doing okay so far? Now, this code does not read really well anymore because the use of indentation is no longer indicating how the program is nested. Is that okay? So we'll fix that. One way to fix it is to go back from line 29 all the way to line 36. We can just insert 2 spaces of all of those lines, which is really kind of cumbersome. So what I'll do is I'll do another trick in VI. You can set up the tab stop of each shift width to 2. So SW stands for shift width, which is basically saying every time we do a shift, which is a VI operation, it will be off by 2 spaces. Now, I use 2 spaces. Some people like to use 4. Some people like to use 8. It's all up to you. I mean, I'm not going to enforce any standards here of how many spaces you have to shift for each level. Now, here's the magic part of it. I go to the beginning part of this one, and I press greater than, which is the shift operation in VI. So greater than. Then I press the close square bracket, which is to say, oh, find the end of the following enclosement symbol. In this case, I'm looking for the closing curly brace corresponding to this level. So now I press the curly brace, which is shift square bracket, and it does almost everything that I want to do, except it shifted the extra line, which is 37. Okay. I know most of you do not remember what I just said, but since it's all recorded, we're good. It doesn't really pay off when you're dealing with like 8 or 9 lines of code, but when you have like 200 lines in between, then it really pays off because it's, it matches the end automatically. All right, so we just have to now specify what do we do to specify there are, as long as there are common factors. What is the indicator that there is a common factor?
If both numerator and denominator is the most not to the same number.
Right? Mm-hmm. Well, there are several things that we still have to do, okay? The first thing we have to do is, in the loop, once we find the common factor, what are we supposed to do with the common factor?
You're supposed to check with the argument.
Divide, right? Divide both the numerator and the denominator by the common factor. So what I need to do now is to say, if there is a common factor, do the following. Okay, the following is easy. That's the easy part. Numerator is divided by f, and then the denominator will be the same. Denominator. Okay. So what do I put here? How do I know that I found a common factor? Sorry? When you can use the same line, okay, so you can basically reuse the same condition, which is this kind of long thingy here, but this time you have to say equal to and equal to, okay, that's one way to express it. There's nothing wrong with that, so let's go ahead and go with that. There's another way to do it too. You can say if f is different from both the numerator and denominator, it is also going to be, it has to be a common factor. So there are 2 ways to express this. So we'll go ahead and go with the first one, the one that you suggested. Okay. Works just as well as the other one. So we say, if the numerator mod f is 0 and the denominator mod f is also 0. Yeah, I forgot that 0. Then we'll go ahead and do this simplification. Is that okay? But when we get to the outer loop here, how do we know that we just found a common denominator? Because we just changed the numerator and the denominator. The mod operation may not work anymore. So how would you do this?
Is it going to be a problem that you're incrementing f before you're dividing?
Sorry?
Is it going to be a problem that you're incrementing the factor before you divide by it?
Increment the factor before I do the division.
Yeah, so you start with plus f.
But the plus f is inside the loop, and the division is outside of the loop. When I exit the loop, f is definitely a factor of both the numerator and the denominator. So it's okay. The code up to line 41 is going to be okay. The problem is by the time I get to line 43, the numerator and the denominator have been divided by the common factor already. So I cannot use the same trick to decide whether I should get out here or not. There's a very easy way to get around this particular problem. You just use another local variable. Okay. In other words, you can use another local variable here. This one can just be an integer here, and it's just quit. Okay. And quit is initialized to no. Okay, let's not quit yet. And over here, we can say else quit is 1. It's time to quit. And over here, we say as long as we are not supposed to quit, stay in the loop. Is that okay so far? I just use one extra variable to clearly, explicitly indicate whether it is time to get out or not. So I think this is all done. Okay, we'll let the compiler have it and test whether it is syntactically correct or not. I might have made some syntax mistakes, and that's what the compiler is for, is to check the syntax. There are no syntax issue here. 507, like the program, and until I find out the program is not working, I'm just going to run it without GDB. So we'll retest the condition of 49 and 91, and it does work. So this is the way I do this homework assignment. Is anyone suspecting that I have rehearsed this for several hours at home, and then just memorize the whole thing and then just regurgitate everything during class? If this is the first time you have taken my class, you might think that. If this is not the first time you take my classes, you know that I don't do that sort of thing. I don't, I enjoy the process of writing programs. I hate memorizing stuff and having to regurgitate stuff. So I really just came up with the algorithm. Some people might have used the word wing to refer to what I just did, but I would say it is not. Okay, I would just say it's an illustration of the development and debugging process. Which I think is very important. I mean, if I just read a textbook to you and say, oh, this is the solution, or this is one of the solutions, I don't think that's going to be beneficial. Actually showing you that, oh, okay, I made mistakes, and this is how I find the mistake, and how I fix it, and this is how I write the program in steps. Okay, I think that part is more important than anything else. I do not even attempt to try to write the entire program in one single session. Okay, I break it up, and each time I only write a small portion, test it, make sure that works, move forward, write some more, test it again. Okay. Are there any questions about the solution of the homework assignment or the process of getting to the solution? Because sometimes you can ask me about the process itself. Yep.
I emailed you last night because
Mhm.
my fraction simplify function was giving me like random numbers after I made sure that it was reading in the fraction right.
Mm-hmm.
So could you tell me what I did wrong?
I cannot tell you because I don't have your code in front of me right now. But when what you can do is to compare your code with my code. Now, unless the structure of your code is completely different, you can usually kind of tell,
It's
where.
sort of similar. I only used one loop.
Okay, you can't do it with one single loop because with one single loop, you need one loop to find a common factor, but you need another loop on top of that to reapply the same logic over and over again until there are no common factors.
Well, mine resets the counter inside the part that tests if it is a factor.
Well, because in your case, if you only have one loop, it will not be able to. My program stopped working. 512 divided by 512 is not. It's an infinite loop. All right. Well, let's go ahead and debug it. Okay. With one single number, it can do it. With two numbers, it cannot do it anymore. So 2 over 2 won't work either. Let's try 3 over 3. That's not working either.
It's pretty short. I could write the logic on the board if you want.
7 over 13. Sorry?
My code's pretty short. I could write it out on the board for you.
Well, I can do it during the lab time. That's what the lab time is for. Okay. Okay. So my code is not working. It worked out okay with a few test cases, but not for the other ones. So from this example, can anyone tell when it is not working? No.
When you have the same number, it doesn't work.
Well, let's try 3 over 6. It can do it. When two numbers are the same, it's not exiting.
Yeah.
All right. So without even going into GDB, let's see if we can find out, what's wrong with the code here. Okay. Okay. This is the process of debugging. If your program is not exiting a loop, it means the condition of the loop is true when it is not supposed to. Okay? So that's what we're looking for. Okay? And we have two loops here, so we have to pay attention to both loops here. With the inner loop, okay, you look at this condition here, and you say, is it possible for this not to be true? And the answer is yes. Okay? Okay. Think about this. What if I give this program 1 over 1? Think about that. If I give the program a numerator of 1 and a denominator of also 1, what is going to happen to the inner loop? F starts with 2, right? So the numerator is 1. 1 mod 2 is non-zero. 1 mod 2 is non-zero. It's okay? So that means the condition of line 33 is true. Now we also need the second condition to be true, the one on line 34. 1 does not equal to 2, right? 1 does not equal to 2. So I will bump F up to 3. And it's going to be the same thing. 1 mod 3 is 1. 1 mod 3 is 1. 1 does not equal to 3. 1 does not equal to 3. It will stay in this loop. So how am I going to fix this problem? I mean, the 1 and the 1 is the issue here. There are two ways to fix this problem. One way to fix this problem is simply to say, change the not equal to basically say, as long as the numerator is greater than f, and the denominator is also greater than f. Because if I change it from not equal to greater than, it will catch the 1. Because 1 is not greater than 2, 1 is not greater than 3, and so on. But once I change this, I also have to make sure the condition on line 40 is not going to get affected. That's not going to get affected, right? Because 1 mod f does not equal to 0. 1 mod f does not equal to 0, so it's not going to accidentally think that 2 is a common factor of 1 and 1. Then it will set the quit flag, and then it will just quit. So without even running through GDB, by the symptom of the program, I have suspicion of the condition of the loops, and I found the one that has a problem, okay? And I suspect this will fix it. So let's go ahead and retest the program and make sure that it does work. Now, when you're retesting the program, you don't want to just retest it with the failed test cases. In other words, in this case, the failed test cases is when I have 3/3 and when I have 2/2. Okay, it fixed this problem. But in the process of fixing one problem, there is a fairly good likelihood that you will introduce another problem, which means in order to fix this problem, I might have introduced a problem to make it not work with the other test cases. So you have to retest every single test case every time you fix a problem. So now I have to go back and check 1/2, 7/13, 49 over 91. So I have to recheck everything that used to be working because there's a possibility of fixing one problem can introduce other problems. Okay. This process, by the way, is called regressive testing. Okay, regressive testing means every time you discover a problem, you find out a new test case to test for the new problem, but you're going to add the new test case to all the test cases that you have already discovered, so that you don't miss anything that you have already discovered. Are there any questions about this process? Go ahead.
Can you test 45/9?
45/9. Okay, so let's try that. 45/9 is 5/1, which is correct.
What about 512 over 512?
Sorry?
512 over 512?
512 over 512. Let's do that. 512 is 1/1. Right.
Just a negative number?
Yeah, negative numbers are not going to work because, well, -1 over -1 is 1/1. But the problem with negative number is when you input -1, it will still recognize it, but it will be represented using the bit pattern of -1 is the same bit pattern of 4 billion something. So that's why when you have -1 over 1, it gives you that number. It's because, the mystery of this part has to do with we are using 32 bits to represent signed numbers, which can go from -2 billion something to +2 billion something. But we can also use 32 bits to only represent positive numbers from 0 to 4 billion something. So that means half of the bit patterns has potentially two roles, right? It can be representing a negative number, or it can be representing a non-negative number. I'm not going to spend too much time in this class for this one, but I would kind of talk about it a little bit, since you asked the question, which is a good question, okay? When you think about numbers in a math class, it's a number line, okay? I think we talked about this a little bit when we talked about representation, but when you're dealing with fixed with integers, it is no longer a number line, it is a number circle, okay? So we have 0 here, going to 1 here, 2 here, and so on. And so let's just consider 4 bits, okay, 4 binary digits. 1 is 0, 0, 0, 1, 2 is 0, 0, 1, 0 in base 2, right? So we can quite easily make up this table. Up to 7, which is 0, 1, 1, 1 in base 2. Those are the easy ones. What about the next one? The next one is, that should be 8, okay? The next one should be 9, right? And so on. So that means the last one, the one right before we get back to 0, should be 15, which is 1, 1, 1, 1 in base 2. Are we still doing okay so far with this number wheel? But that's only representing non-negative values. In other words, this is unsigned. So if we have a regular signed integer, what's going to happen? If you have a regular signed integer, this one should be -1. So that means we are using the bit pattern 1, 1, 1, 1 to represent both -1 and 15. Now it depends on how you call that type. Are you naming that type as unsigned integer, or are you naming it as just regular int? If it's regular int, it is -1. If it is an unsigned integer, it is 15. So printf in scanf does not really care. So scanf would take in the -1 and use the 1111 representation and store that. But when we refer to it for calculation purposes, and also when we do the printf, it would use the unsigned interpretation. Then that's why the huge number is printed. Yep. So it is an issue with printf itself. When you specify the format string %u, it should not have recognized -1, and that's I would consider that a misinterpretation of the standard. So the implementation of printf is I would say is incorrect in this case. All right. So it's not your bug. It's just the way scanf
You gave a
works.
test case on Monday of a negative number
Right.
coming out with a positive number.
Right.
So, and I couldn't get that to function.
Yeah. But that's why I sent an email after that and go like, oh,
I
forget
never
about
looked
negative.
the email. I read the
Oh.
technical publication and went, no, that's not how scanf works. It's, so,
Yep, it's time to report that error to the GNU organization. That's the whole thing about open source is you can fix it too if you want to.
I'll pass.
You'll pass. For now anyway.
Right.
But at some point you guys will have the ability to fix all that too. All right. So are there any questions about this program, about the process of writing the program? Because I think the biggest question is going to be the process, not so much the details. Okay, so what I'll do is I'm going to give you a spring break gift. So I'm going to write a subroutine to initialize arrays to 1/1. But it's going to be an array of fractions. So it will resemble a little bit of your homework assignment. It will explain some of the concepts that you need to know to do your homework assignment. All right, so I will just put it in the parent folder here. I'll just call it init fractions. All right, so without using the header file, I'm just going to redeclare everything here. And I'm going to be lazy and not spell out the whole thing. stdint.h. So depending on what you're using, you have to include the correct header file. In order to use uint32_t, it has to use stdint. But since I'm not going to use any printf or scanf, I'm not going to include include stdio.h. I don't need that in this case. So I would have a subroutine called fractions init, okay? And what it will do is it will take in an array of fraction structures. And I will call this array. And this is how you declare that the parameter array is an array of fraction structures. And in the main subroutine, I will do this. This is actually resembling your homework assignment. So in the homework assignment, I have a main, and in here we have const int. Number of fractions is initialized to 5. And then I would also have a struct fractions of fraction, and let's just call it R, or array A. Okay, we'll just call it A here. This is declaring that A is an array of 5 fractions. And I would call the subroutine called fractions init. Oh, got one thing here. I have to tell it how many elements it has. So I have to pass a second parameter n to specify that. So now I would pass A as the first parameter, and I would use num fractions as the second parameter, and then return 0. Okay. This is resembling a little bit of your homework assignment. I have a subroutine that takes in 2 parameters. The first parameter is an array of fractions. The second parameter is the number of elements in that array. Now this is something that's kind of unique to C. When you get an array, there's no way you can tell how long or how many elements are in the array. So you need a second argument to basically say, oh, this is an array, and this is how many elements it is supposed to have. And that's why we have two parameters. One is array and one is n on line 8, because they cannot be combined. There's no way in C that you can combine these two. Line 15 is declaring a constant. It simply means every time we see num fractions, it's the same as 5. So this way, if I want to change the program to deal with 50,000 fractions, I just change one line of code and the rest of the program will work the same way. Is that okay? And then line 16 is the declaration of an array of fractions. How many elements do we have? 5. So we have an array of 5 elements, which is the local variable a in main, and I'm passing that array to the subroutine fractions in it. Are there any questions about the structure of this code at this point?
So you don't have to pass an array as like a pointer, do you? Because it's
That is correct. You do not have to pass an array as a pointer. And there are several reasons why that is the case, and I'm not going to get into that just yet, okay? But this is how you pass an array. It's just an array.
But it's still gonna, if you modify the array in the function, it's still gonna modify.
That is correct.
Okay.
Yep. There is, okay, to answer your question, the short answer to your question is there's no way to pass an array by value. Okay, to use terminology from cisp360, in C and C++, you cannot pass an array by value. The only way to pass an array is to pass, quote unquote, by pointer. Okay. So inside this array fractions init subroutine, I would need to use a local variable I. And this time I'm going to use a for loop. For I is initialized to 0, I is less than n, and post increment of post operation of incrementing I, this is what I'll do. Okay, I'll just say array. What is array? As a parameter, what is it? Well, okay, I'll give you a few choices here, and I'll give you something that is, well, at this point it should not be confusing, but later on it will be confusing. Is array a fraction? Is array a pointer to a fraction? Or is array an array of fractions? Pick one of the three. The third one, right? Array is an array of fractions. So if it is an array of fractions, how do I get to one element of the entire array? Indexing the index operator, which is in the form of square brackets. Okay, very good. So we use square brackets here. And inside the square bracket, I can indicate which element of the array I want to access. From the way I set up the loop, what do you think that would be? I. Mm-hmm. Okay. So what do I have now? Array bracket I. What is that? Is an element of the array, which is a fraction, exactly. Can I do something like this? Well, if you look at the type of the left-hand side of the equal symbol and look at the type of the right-hand side, do they match? One is a fraction, one is an integer. They do not match. Okay, so what do I need to do? Well, with a fraction, I can access a particular member. There are two in this case, so I'll just go ahead and access the first one. Remember, this time I used the abbreviation n, okay, not numerator. So this is the first one. And I can do it to the second one, which is D, just like that. So this will initialize one particular element at index I to 1 over 1. Are there any questions? Okay, sure.
In this case, you force that the numerator and denominator become 1.
Say again?
You force that the numerator and denominator will
Yeah,
become 1.
I'm initializing this array to just 1 over 1. So I'm initializing every single element of the array to 1 over 1. That's all I want to do. Okay? All right, so let's see if this is actually going to work the way I think it should be working. Okay, so let's go g++-1 all-g-c init fractions.cpp. No compile time error, which is good. We'll do the linking here. Init fractions.o. and then we'll GDB it because there are no other ways to tell whether this is working or not. So we'll have to use GDB for that purpose. Put a breakpoint in main, run the program. Now I'm in main. We'll go ahead and print the entire array, which is A. This is the entire array, which is great. It tells you that the array has 5 elements, okay? Because this is the first element, this is the second element, from here to here is the third element, this is the fourth element, and this is the fifth element. Not the name of the movie, but the actual element, last element of the array. I can tell how young people are when there's no or few response to that particular statement, not the name of the movie, and they go like, what? Fifth element, is that a movie? Yes, with Bruce Willis and, you know. All right, does that look initialized to you? It has all kinds of gibberish, right? Okay, but that's great because now I can run the subroutine to see if the subroutine is going to get it fixed. So what we'll do is we'll put a breakpoint at the end of the main program. In other words, I'm going to say, oh, I'm so confident about the subroutine that I think it's going to work. Okay, so put a breakpoint on line 25. Let the program run at full speed until we get to line 25, and then we'll print A again, which is the array. And what do we get? So all becomes 1 over 1. So the subroutine does work. Okay, and this is what you need to do to get started with your homework assignment, which is to find the least common denominator of a whole bunch of fractions, and then change both the numerator and the denominator of each one so the value represented is not changed. Okay, so I will explain that part a little bit more just so that you know what your subroutine is supposed to do. So we'll go to, say, mouse pad here. So let's say I give you 3 fractions, okay? 1 over 3, 2 over 5, I don't know, the next one is 3 over 2, okay, that's it, okay? So the first thing I have to do is to find the least common factor of 3, 5, and 2, which is going to be
1.
No. Least common denominator. 30. Okay, so 30 is a good one. So that means, you know, I have to change both the numerator and the denominator so that they do not change the value they are representing. With a denominator of 30, how do I represent the value of 1/3? Right? And 2/5? And 3/2 would be?
45.
Yep, that's it. So given the input like this, I need your subroutine to end up with this. That is the idea. Let's go through another example. Let's pick 4 over 5, 8 over 10, and 16 over 20. So in this case, what is the least common denominator? 5 is the one because you can simplify everything to 5. So this is a good indicator to mean that, hey, fraction simplify may be useful in this particular program. But tag, I didn't quite get my simplify subroutine to work. Copy mine. Stop the screen when it's displayed. Just copy my code into your program. Okay, make it your subroutine. Okay, you're allowed to do that. So in this case, the output is 4 over 5, 4 over 5, and also 4 over 5. Are there any questions about this particular program? Apply simplify first, okay? Then look at all the denominators to see if you can find the least common one. Yep.
I think, yeah, in the comments of what you gave us, it says it's like given 32 over 4, 20 over 5, and 1/3.
Mm-hmm.
And it comes out as 24 over 3, 12 over 3, and 1 over 3. So it's like they were all like raised to whatever
Right.
Would be the common denominator, but then simplified down, but only to 3. When the
Okay,
first two
let's take a
could
look
be
at the.
simplified.
It is in the code, right?
Yep. Yeah.
Okay, let's take a look at it. This is in arrays. Okay, so with this one, if there are 3 fractions given, 32 divided by 4, 20 over 5, 1 over 3, then the result should become that. But that is correct.
Yeah, it's correct. It's just that yeah, well, it could be simplified more, but it's the fact that like.
Well, it cannot, because it cannot be simplified any further, because the end result, okay, whatever you end up with in the array, they must have the same common denominator.
Okay.
So that's why you cannot simplify it any further. You simplify before you get it into your logic. Okay. So you simplify 32 divided by 4 to 8 first. You simplify 20 over 5 to 4 first, and you cannot simplify 1 over 3. So out of 1, 1, and 3 as the original denominators, you have to settle with 3, because that's the only way you can make them all have the same denominator in the end.
I was doing it in the reverse order. Like
Oh, okay. Yeah, simplify first and then apply the logic.
Okay.
Because the idea is I want to prepare all the fractions so you'll be ready to perform addition. So they have to have the same common denominator at that point. Is that was a good question. I just want to make sure the whole class understands what I was talking about. Okay. All right. Any other questions? Well, how would you do that? I mean, how would you find the least common denominator given a whole bunch of numbers? If I just give you, I'm going to use mouse pad here. If I just give you a few numbers, how do you know, what is the least common multiple of those numbers? Because that's basically what you're trying to find, the least common multiple of those numbers. So otherwise known as LCM, right? Okay. So I'll just give you a few examples. So I'll give you, I don't know, 15, 20, and 10. Okay. So what is the least common multiple of these 3 numbers? Least common multiple. Okay, in this case, it's actually 60, but this is because we have not simplified these numbers yet, right? But because you would have already simplified the numbers before you get to this step, so 60 is the correct answer. Okay. If I give you, I don't know, 7, 3, and 5, what would be the least common multiple between these 3? Well, since these are all prime numbers, so that means it's going to be the product of these 3, okay, because they do not share any common factors. So in this case, it will be 21 times 5, which is 105. Okay. So what you want to do is to find out how to find LCM. Okay, and there are YouTube videos that you can watch for that one. Okay, LCM, just look for LCM. And if you look for LCM and GCF, there's a song for that, and a rap version of that. That is interesting. So here you can look up any one of these, and it will give you an idea of how to get started with your homework assignment. Are there any questions about finding the LCM, which is basically the bottom line of this particular program? And also how to access individual elements in an array. So let me go back to the program itself and see if I have any questions about that portion. Look at oops. There we go. So are there any questions about line 14 and line 15? Because you will have something similar to this in your program. You start with an array, you get to an element, but each element is a structure, so you use a dot notation to get to each member of the structure. Is that okay? So we are just basically using the operators one level at a time. Now, if you want to group these things using explicit parentheses, this is how it is operated. So the first thing we do is the indexing operator on the array, and then the second thing we do is the dot notation to access a member of each element. All right. Any questions about this? And once again, you can reuse code from my solution of the homework assignment due today. So in case you have doubt about your solution, don't worry about it. Just use the solution that we have talked about today as a starting point. Any other questions? No other questions? This is going to be due on the Wednesday after spring break. So it's not going to be next Wednesday because it's spring break. I cannot make any homework assignment due within a spring break. Any questions? If there are no questions, I'm going to stop the lecture and we'll go ahead and start the lab portion. For those of you who want to get this all done before spring break so that you don't have to worry about it, let's go ahead and get it started and see how much code we can crank out today so you don't have to worry about this over the break.